Direct variation is our topic today. This is probably one that you've never even touched on before. We'll find out. Maybe you have, maybe you haven't. I don't know. You've dealt with lots of things that show direct variation. You just never knew it. So, what even is it? It's basically when I have two quantities, usually something along the x-axis and the y-axis, and they are related. They go up together or come down together at the same rate. Okay? And they also have to pass through the origin if you were looking at a graph. So, direct variation relationship between two variables where they increase together at the same rate. And pass through the origin. So let me give you some examples of things that have direct variation. How much you get paid per hour, how much you get paid and the number of hours that you work. If you work 0 hours, you get $0, right? So there, that would be it reflecting passing through the origin, right? And then let's just make it easy. Say you make $10 an hour. If you work 1 hour, you get $10. You work 2 hours, you get $20. 3 hours, you get $30, right? So they would increase together at the same rate. And that rate is that $10 per hour, okay? So for example, number of hours worked and pay would have a direct variation relationship. Another example might be the total cost of going to the movies and the number of tickets that you buy, right? If you don't buy any movie tickets, then it doesn't cost you anything. If you buy one ticket, it's going to cost you whatever one ticket costs. 2 tickets cost you whatever 2 tickets cost, and so on and so on and so on. If you're buying tickets for 15 people, it's going to cost whatever 15 people cost, right? So another example, number of movie tickets and total cost. Now, there's an equation for direct variation. It's pretty easy. You are going to want to remember it, but it is very nice. Nice and easy. So here is the equation for direct variation. It's simply y equals kx. That's it, y equals kx. So x and y are just the two things that you're comparing. So in my last example, total cost would have been y, number of movie tickets would have been x. So what do you think k is? What'd you say? It is! Have you heard of this before? K is the constant of variation. Have you heard that phrase before? Is that somewhere in your memory? So K we refer to as a constant of variation. So, in the particular example for the movie tickets, K would just represent how much one movie ticket is. And that doesn't change, right? It doesn't matter if I'm 2 people going to the movies or 6 people going to the movies. As long as everyone's an adult, we're all going to pay the same rate, right? It would just matter. The total bill would depend on how many people I'm buying for. Is it 2 people or 6 people or 10 people or whatever? But the cost per ticket doesn't change. Same thing, go back to the example about the number of hours you work and your pay. The constant variation, the thing that doesn't change, is how much you get paid per hour. So if you're getting paid $10 an hour, it doesn't matter if you work 2 hours or if you work 20 hours. Does that make sense? So that K constant, right? That's what I want you to remember. That's a thing that doesn't change. It doesn't matter how many I buy, if it's movie tickets, or how many hours you work, or whatever the example is. K, the constant, is the thing that doesn't change. So, one thing I'm going to be asking you to do is I'm going to give you an equation, and I'm going to ask you if it does model a direct variation relationship or not. Here's how to tell, okay? So, let me write the directions exactly as you'll see them. It'll say, determine whether each equation is a direct variation. All right. Determine if the equation is a direct variation. So let me give you a couple. Okay, so here's 4 examples, and we're going to go through each one and determine if it's direct variation or not. So, basically what you're trying to look for is, does the equation look like this one, where you have y equals some number times x? And if it doesn't look like that exactly, is there a way you can make it look like that? So if I look at the first one, does this look like y equals some number times x? It sure does. So that, yes, absolutely is direct variation. So this one, let's see, let's pick a, oh, green, my favorite color. Yes. That is a direct variation. How about 2? No. Why do you say no? Yeah, it doesn't fit this form. It doesn't look like y equals some number times x. What I have is y equals some number minus, or I'm sorry, the variable minus 4. Well, nothing in my equation for constant direct variation, nothing has a minus in it. So this thing can't be. And there's nothing I could do to this to sort of rewrite it so that it's some number times x. So this one is a no. What about 3? Oh, Pablo's quick to say yes. Think on this one. Do you have y equals some number times x? Yeah, it doesn't matter that that number happens to be a fraction. It doesn't matter. It still is y equals some number times x. So that is a yes. And the last one. You're confident here. I'm going to give you some tougher ones in a second. But he is right. This is a no. Even though it is y equals some number times x, you have this plus 1 here. And that doesn't fit the equation that I had here. I can't have plus or minus some other thing. So that is going to be a no. Okay. That was the easy round. I'm going to step it up a notch. Are you ready? Let's try. Same rules. Tell me if it is or isn't. Ooh. These are tough, some of them. So when you're looking at 5 through 8, you want to think, is there a way I could rewrite this without changing its meaning, right? Like, for what I mean by that is, you know, instead of writing 2 plus 3, I could write 3 plus 2, right? And that doesn't change anything. That hasn't changed its value. Can you manipulate the equation in such a way that's legal that makes it look like y equals kx? Because right now, when you look at number 5, that doesn't look like y equals kx. Because I have 3y equals 2x. So, Olivia, you have a thought? That's a great idea. If I divide both sides by 3, that at least gets that y by itself. Couldn't I now write this like this? Y equals 2/3 x? Can't you write it like that? And is that direct variation? It sure is. Y equals some number times x. So that's a yes. So even though at first glance it didn't quite look like it, I was able to manipulate the equation a little bit. Now, in 6, y is already by itself, but is this y equals some number times x? Right. Could I write it in such a way that it does look like y equals some number times x? Think on this, guys. Okay, here, maybe yeah, go ahead. So how might I write this equation so it's the same thing? You're right, but you want it the other way. Because right now, the denominator is a 6. She's doing keep, change, flip, I think, right? So if you keep the numerator, x, change to multiplication, now you need the reciprocal of 6. So wouldn't that be 1/6? Right? And then, couldn't I that's just multiplication, couldn't I now just write it as 1/6x? You could have also jumped right from here to here. If you divide by 6, it's the same thing as multiplying it by 1/6. Right? Those are the same thing. So, yes, you can manipulate that equation so that it looks like y equals kx. And then k would have just been 1/6. So this is a yes, number 6. How about 7? So, kind of the same idea, right, as the last one we just did. So I was able to rewrite that as 1/6 times x. Can I kind of do the same thing here? I can. I could rewrite this as 1/4 times x plus 2. Is that going to be in direct variation form, though? No. So you can rewrite this like this. 1/4 times x plus 2. That's totally legitimate. You can do that. But this still doesn't fit the pattern because I have that plus 2 there. So this is a no. So y equals, I do have some number, but I don't just have x. I have x plus 2. So that's going to be a no. Now 8. Ooh, this one looks tricky. Olivia, what do you want to do? Good idea. I would minus 2x. Always try and get the y by itself and see what it looks like once that's accomplished. All right, so now if I'm trying to get that y by itself, what would I do here? Go ahead. You got it. Divide both sides by 8. So now, couldn't I write this as negative 1/4 x? And is that direct variation? Yeah, I have a negative. I don't know if you can see it. Oh, you want the negative down on the 4? Oh, okay, yeah. Well, that's a good question. Is it still direct variation if that number's negative? Yeah, it doesn't matter. It just has to be some number, any number, times x. Positive, negative, doesn't matter. So y equals some number times x. That's a yes. Okay, does that make sense? Yeah, everybody's good so far? The other way that you can tell if something is direct variation or not is going back to this piece right here that it has to pass through the origin. So if you were to look at the graph, so remember last week we were picking some values for x, plugging them in, see what we got out for y, and then we would plot them and then connect them in a straight line. Remember that? So if that line just so happens to pass through the origin, then yes, it's direct variation. So you could do that as well. So say I did, I don't know, say I was to do this one, y equals 3x. If you were going to graph that, remember we were picking negative 2, negative 1, 0, 1, and 2. So if I just plug those in quickly, 3 times negative 2, that would get me a negative 6, right? Pop in a negative 1, that's a negative 3, 0, 3, and 6. So I'm just going to sketch this graph real quick. You already know the answer. Is this thing direct variation or isn't it? Yes, because we just talked about it. It fits the form. Y equals some number times x. But watch, you'll see that when I graph the graph, it's going to, well, I mean, you see it right here. It's going to go right through the origin. Negative 2, negative 6 would be somewhere down here. Negative 1, negative 3, 0, 0, 1, 3, and 2, 6. So yes, direct variation for both reasons. It fits the pattern, y equals kx, and the graph passes through the origin. Okay, so if you had some graph and you graphed it and it didn't pass through the origin, can't be direct variation. Okay, so far so good? All right, now we're going to try another style problem with direct variation here. They're kind of fun though. I'm going to write it just like they have it on your homework tonight, so there's no confusion. So if y equals 14, when x equals 5, find x when y equals 28. I'm going to give you some step-by-steps here. It's really not bad once you get the hang of it. So, how to? Step 1. Use y equals kx and plug in the first x and y given. Okay, ready? So, I'm literally going to write y equals kx, and then I'm going to replace, it says, use y equals kx and plug in the first x and y given. So, if you look in the problem, see how there's two different y values given? There's one that's 14, there's one that's 28. And then as far as the x's go, I only have one x and I don't have the other one. So, it can get a little confusing. Well, which one goes where? What am I doing? It's whatever they first give you. If y is 14 when x is 5, that is the first part of my problem. The y being 28 comes in later. Okay? So I'm literally just going to replace y is 14. I don't know what k is, so k just stays in there. But x is 5. So there's step 1. You just plug in x and y. Step 2, now all you have to do is solve for k. So if I want to, solve for k, what do I have to do? Don't I want to divide both sides by 5, right? Yeah, so that's 2.8. Now we're almost there. Step 3, you're going to now go back to y equals kx, but now you're going to plug in k and the other information. So I'm done with the 14 and the 5. I already handled that. So now I'm going to plug in the next bit of information. The next bit of information, I don't know what x is, but I know that y is 28, and guess what? I now also know k. All right? So go back to y equals kx and plug in the k you just found. And I'm going to say the second x or y, whatever you're given. Okay, so I'm going to rewrite y equals kx, but now I'm going to plug in the new info. Find x when y is 28. So y is now 28. K is 2.8, and it's x that I don't know. You see that? And now I can just solve for what's left. Exactly. If I want to get x by itself, now I'm just going to divide both sides by 2.8. So that will be step 4. Solve for what's left. So in this case, divide by 2.8, divide by 2.8, and that's going to get me 10. Cool, so that means when y is 28, x is going to have to be 10. Does that make sense? Everybody's all right? Okay, let's try maybe one or two more together. Let's say if all right, I'll do this one. Ooh. I'm just looking at the way one of these is worded, and I'm realizing that my how-tos might be a little confusing then. So let me do it this way so that we can clarify. Find y when x equals 3 if y equals negative 3 when x equals 6. All right, I need you to sneak in a word into step 1 to make it make sense here. And actually, let's get rid of the word first. Get rid of the word first. And then right after you have x and y, I need you to sneak in the word pair. X and y pair. Use y equals kx and plug in the x and y pair given. So let me explain what I mean by that. Look at our problem now. Find y when x equals 3 if y equals negative 3 when x equals 6. These two are paired together. This, the find y when x equals 3, that's the part I'm going to do later. This is the pair that I need to start off with. Okay, so now if we reread step 1, it should work out a little bit better. Use y equals kx, so we'll start there, y equals kx, and plug in the x and y pair given. So what am I going to plug in for y? Negative 3. K is what I don't know. What do I plug in for x? 6, right. I want to plug in the two that are paired together. Negative 3 and 6, that x and y are paired together. This one, I don't know what y is when x is 3, so I don't know that pair yet. That's what I'm going to do in step 3. Okay, so step 2 now says solve for k. All right, that's easy enough. Divide both sides by 6. What is negative 3 divided by 6? Negative 1/2, correct. Okay, now I know what k is, so step 2 is done. Step 3 says go back to y equals kx and plug in the k you just found and the second x or y, whatever you're given. Let's change the word second to other. Sorry, I didn't even think about them being able to write the problem in this other way. All right, so I want the other x or y that I've been given. So do I know what y is now? No, that's what I'm trying to find. It says find y when x equals 3. So I don't know what y is. I do know what k is, though. I just found it, negative 1/2. And then x, my new x, is going to be 3. So what is y? Negative 3/2. That's it. Is this all right? Okay, so I think I'm actually going to stop here.